Hey, do you want to say hi? Yeah, leave that there. Do you want to say hi? You sure? So okay. Can someone, if you can hear me, can someone please say or type that you can hear me? Okay, great. Thanks, Nita. Okay, so this will be the last class where we introduce new material. What we'll do is we will meet for an hour, we'll have a break, and then we'll finish up the file system discussion after the break. And then at about 11:20, one of our grad students, Barush Doruk, will give a presentation that you guys will all need to stick around for and view that. And if there's time permitting in the semester before I have to have all the grades finalized and entered, then I will give you I'll give all of the undergraduate students a task related to the graduate students' presentations. I don't want those to go to waste. I want to make sure that you guys have listened to those and paid attention to those. Okay, so let's go ahead and begin with we're going to finish up this week again on file systems. Let's see. Let me share. Where are you? There you are. Okay. All right, so today, chapter 14, I've uploaded to the shared drive the lab for this, the practice sections for this as PDFs. So hopefully you've gotten access to all those. I did that this morning. So some of them were already there. I'm not sure why not all of them were. I guess I just didn't copy them all over. I don't know what happened, but basically now you should have access to all of them. Okay, so we're going to talk a little bit about how the file system hierarchy and how to access files, and both locally and remotely files that are on your local machine as well as a remote system. Okay, so get straight into it. So basically, the way that files are stored, and if you've had any type of computer organization or computer architecture course already, to some degree a digital systems course would also cover parts of this. Basically, a file is stored in memory, whether it be a RAM or hard disk. A file is stored as a series of ones and zeros, a series of bits, and organized into bytes and all that as well, megabytes and all those bigger size things. All right, but they get stored onto the system into these memory storage units, and we need to be able to find them though. We need to be able to find what data, what bits belong to that file. Okay, all right. So basically we have, so you can have hard disks, right, that can be divided up into what we would call partitions. So for example, on this computer, I don't have this one set up this way, but this computer that the university gives me for use for work and for course teaching is a Windows machine. It's a Lenovo ThinkPad, but it has the Windows operating system on it. Now, what I could do if I wanted to is I could partition the hard drive on this machine, which, if I remember correctly, is 250, I think, 250 gigabytes. Maybe it's 500. I honestly haven't looked in a while, so I can't remember. But what I could do is I could partition this this computer into multiple, like, smaller drives, basically. Okay, and then if I wanted to, what some people will do is they will keep like the Windows operating system on one of those partitions, but then another partition could be a Linux operating system, uh, or you could keep multiple partitions into and keep multiple partitions into have multiple operating systems that you can boot into. Right now, what I'm doing for this course is using a virtual machine instead. And what the way that the virtual machine, as you guys have seen me use here, the way that it's set up is what I do is I take a portion of this hard drive and dedicate it to that virtual machine. So what happens is when I start up that virtual machine, I believe I've given 40, if I remember correctly, 40 gigabytes over to that virtual machine. And what happens is when that virtual machine is running, it has 40 gigabytes that it can use for different stuff. Okay, and those 40 gigabytes, if I make them dedicated, not dynamic, then what'll happen is this Windows operating system can't even use those. All right. So anyway, so that's how partitions work. Okay. Now, let's see. As far as other types of storage devices, you know about external hard drives. I'm sure many of you have an external hard drive that you use for different things, or thumb drives, portable USB drives as well. What is it? Can't remember. There's one of my graduate students who said he stopped using thumb drives and he's using more often. I can't remember. It's a disk. I can't remember the word he used. It's like a camera, basically. Like, sorry, the word escapes me. But basically, it's another storage device. Okay, and so what happens is that when you put that USB drive in, or whatever storage device you might be using, it does what we'll talk about today. We'll call it mounting. So it'll mount it onto there so that you can use the stuff in there, and you can write the data to there. You can read from it and do different types of things like that. And then when you want to stop using it, you unmount it. So it's you disconnect it. And so for like a USB drive, this is really important, or at least it has been in the past. There are things that they're doing better with that technology now that make this less required. And when you unmount it, it disconnects the drive and makes it to where there's no connection still, so that it can be removed easily without causing potential problems. Okay, all right. So that's about the partitions. If we wanted to examine some of our file systems, we could use the df command to be able to see different information like disk space, what was the free disk space, what's available. We'll go through an example on the virtual machine. Okay, and we'll be able to see what different file systems are available to us and what kind of size usage we're talking about. Okay, we can also use the human readable option by using the -H, because up here we have this whole 1 kilobyte blocks, and that's like big numbers, and humans, we don't really work well with understanding necessarily what these big numbers mean, and so kind of a better way that we can show it would be through this, like 3.9 gigabytes are used. Now remember, I don't know if you guys have covered this in your computer organization or not, but when we say a kilobyte, we don't mean literally 1,000 bytes. It's actually like 1,048, I believe. Yeah, and it's 2 to the 10th power, which would be 1,024. So what happens is it's close to 1,000, but it's not exactly 1,000. right? And so that's why you might see, wait a second, this over here is 4 million, right? Is that million? Yeah. But it gets translated as 3.9. That seems weird, right? And the reason for that is these are 1 kilobyte blocks, right? So this is 4 million kilobyte blocks, but the 4 million is that's a literal number, but the gigabyte is based on 2 to the power of something. So a kilobyte is 2 to the power of 10. A megabyte is 2 to the power of 20. A gigabyte is 2 to the power of 30. And so they're not exactly 1,000, 1 million, 1 billion, but they're really close. And the reason why we report them this way is not to be kind of deceptive or anything. It's just that it's close, and the 2 to the power of is useful in binary systems such as computing. Okay, so anyway, so that's why sometimes people will get kind of weirded out by seeing a number such as 4 million up here and say, well, wait, that's 4 million 1,000 size blocks. Why is it only 3.9? And they'll think that something's wrong, or that the computer doesn't know how to do math or something like that. When in actuality, it's just they are lacking understanding of what the terms kilobyte mean in this context, or gigabyte in this context. All right. So that's why, but the human readable can help us with kind of more of an estimate, like so 3.9 gigabytes and stuff like that. All right. Okay. We can also see a disk usage report, right? Which would be, again, same thing with before of the -H for the human readable. So the space used by a specific directory tree, like specific location. Okay. Right. And so we can see, okay, this uses 4.9 megabytes. This particular folder uses that much, and this folder uses that much, and so forth. Okay. Now it'll be just the files and folders directly there. So it'll be, so here, if we look in the var log, we're going to see the files inside of the var log. If we look inside of the root directory, right, we'll see stuff inside of the root directory. Okay. All right. And then a total down here as well. Okay. All right. And it'll just be the stuff inside of the folders inside of that root directory. Okay. We'll walk through. It's okay. Wait. The practice here is a quiz, so we'll walk through some examples then after we come back from the break. Okay. So what I'll plan to do is I'll spend the first part of this lecture doing these doing the lecture part, going through the material. Then we'll come back after the break and do some examples on the virtual machine, and then have our presentation. Okay. All right. So what I talked about earlier was I talked about mounting and unmounting file systems. So you've done this before, like I said, with using a USB external device, such as a USB hard drive or a USB thumb drive. When you plug it in, now for a Windows machine and most operating systems, when we plug it in, immediately it mounts on its own. Like there's commands inside of the system running that will automatically mount it, so that we can immediately start using the device. Okay. Now what happens is that when the mount happens, is what we're saying is we want to be able to access the data that's inside of that device, and it will be treated, again, like I said earlier, like we talked about partitions in the last section. It will be treated as a partition of memory on the file, on the system. Okay. So when we mount, let's see. well, we can get an idea of what partitions are already there, but when we mount, it gets all the necessary stuff to make that target directory accessible. So when we mount, let me go over the command here. Mount, we're going to specify what file system we're going to mount and what target directory where it should be made available. Okay, the target directory being called the mount point. All right. So let's look at a couple of examples of the mount command. Did they? Oh, there it is. Okay, I just need to scroll down far enough. Okay. So here, okay, again, the first part of the command is we're going to have the part of the partition holding the file system. Okay, so we're going to mount this. We're going to mount this, right, to this my data location. Now what will happen is from here on, we will use this as our location, okay, to be able to get to that data, to be able to get to the stuff that's on that partition. Okay. It will be just like we use any other way to access any other information. This will be considered its path to get to that system. We can also give it a unique ID. Okay. So here, this UUID. Right. So here it's similar. See, I think they did a typo here because I think this is supposed to be both the same. Yeah, I think they did a typo. It should be VDA1 here. So we're mounting this partition to this location. We're mounting this partition with this UUID to this location. Okay. Now, if we are doing stuff on a device, doing stuff on a partition, and it disconnects on its own, like it disconnects, the power would go out to it, or any type of ways that don't really happen as frequently these days, but did back when I was your age. This would happen. This could happen. This was I'm not sharing my entire screen, but if you were to look down in my tray down here, if I have a device that's connected to a USB drive, I would click on that and say, I want you to disconnect that device. And what would happen is it would unmount it. Now, it doesn't physically shoot it out, right? What happens is electronically it disconnects. It closes all the connections to that device. And then once that's done, I can pull the USB drive or stick out, and it won't cause any problems to the data. Okay. Again, this does not happen as frequently anymore because technology has advanced. But not that long ago, if you pulled a USB stick, a USB drive, out of the USB port of a computer, especially a Windows machine, without first disconnecting it through your tray, through the device driver, if you didn't disconnect it and you just pulled it, you just yanked it out, then it could actually cause a lot of data corruption and a lot of data problems inside of that drive, right? And that's what the U-mount, the unmount is all about. Is it saying, okay, I want to unmount this. I want to no longer use that. Now, again, it does not do anything physically to the device. It just simply says, I'm not using that anymore. Now, if you are in the middle of it, so for example, if you've ever tried to disconnect a USB drive while you had a file that was on that drive open, or it was doing something, you might get an error. You might get a, hey, I can't disconnect this right now. And that's basically what's going on here. Is we've said, I want to go into this folder and I want to do some stuff. So now I'm accessing this folder. I am in that folder right now. If I try to unmount it, I say I don't want to use it anymore. It's saying I can't do that. I can't disconnect that because it's busy. There's somebody in here. Okay, and who's in it? Me, actually, right? So you cannot disconnect. You cannot unmount a file system from your system while you are inside of that file system. Okay. Now, we can, while we are inside of that, we can list some open files and processes to see why maybe we can't unmount it. So here I'm inside of it. I'm going to list open files and processes and that are inside of this location. Right? And look, it's me, right? This is me. This is me. That's inside of the folder. Hey, look, this is also me, right? This is me running a command about this folder. So there are actually, in this situation, we could look at it and say that there's two things that, well, three technically if you do this other one too, three things that are accessing that same file system from me. One is this bash that's I'm inside of it. So this part right here where I'm inside of that folder, that's what this is. That's what this is saying. Okay. And this is the one that prevented this command from happening. Okay. And then there's also this command that's saying there's somebody running a command on this file system to get some information about this file system. Okay. So these are the things that are running. Usually, if we're trying to unmount something, but we are not currently in it, and we get this information, we get this like target is busy error message, we'll use this LSOF command to be able to see who's running stuff in there. Because if we're not in it, and we know we're not in it, but for some reason it says it's busy, that means somebody's in that file system doing stuff, possibly, and we need to, and if we want to unmount it, we got to figure out what's going on in there, right? Okay, so here, what we've done now is we said, okay, now what we can do is, again, we can, especially if we know for certain that the stuff that's going on inside there, maybe it's somebody left their computer on for the weekend and they left themselves inside of that drive. They left themselves inside of that file system. It could be that somebody, with a bad purpose, has gotten into it for some reason. What we can do is we can say, you know what, we can kill those processes as long as we know that they're supposed to be killed. And then once all the processes inside of our file system are killed or done away with, we back out of it. Okay, we get out of it because now we're not in it. We're not running anything in it. No bash, no other commands, and we unmount it, and it disconnects. Okay. All right. So this is how you would unmount a drive. And now from this point forward, if I try to access this, it's going to say, you can't do that. There's nothing there. Okay. All right. Let's see. All right. Again, to safely remove the USB media, we should unmount it before physically removing it. Okay. We can result in data loss, data corruption, all kinds of issues. In a way, it's kind of like if you've ever burned a CD and you've had to close the session before you can remove the CD from your burner. It's in a sense it's like the same thing, not entirely the same, but you kind of get the idea that I hope you get the idea that you have to make sure that all activity is done between the two devices before you disconnect them. Okay. All right. So again, we'll go through this practice. I may try to see if during the break if I can find a USB drive to be able to use to do this on our virtual machine. All right. Okay. Now this is one very important part. This section right here about making links between files. It's really short, but I'm going to spend some time here, okay? Because this is one of those things that's kind of important for us to understand. Okay, there are two types of links that we'll talk about: hard links and soft links. And it's a way to make links between files. Now, when we've looked at that ls-l command, okay, you guys, we've talked about what all this means. You should know what this means, what this rw dash r dash dash r dash dash. You should I should be able to ask anyone in this in this room, anyone on this call right now, what those mean, and you should be able to tell me exactly what that means. Okay, so that's not what we're talking about now. Same thing with this. Why root is here, why root is there. Okay, and some of this other information as well. I should stop highlighting. Gosh, stop. Okay, same thing with this and this. Okay, but what we haven't talked about so much yet is this, and that's what we're going to cover today. This one that is valuable information. Okay. Now, what that one is telling us is that there is one hard link to that file. Okay, which means that there is one way to get to that file through the file system. Okay. But we can create other paths to that same file. All right. That's what this is all about. This is the hard link count. All right. Now we can create new hard links to an existing file. And what I'm going to do in just a moment is I'm going to switch over to the whiteboard. I'm going to show you kind of how some of these hard links and soft links operate. Okay. The hard link says we can use a different way, a different path to be able to get to the same file as before. Okay, so here, this ln command, so here we have this new file .txt. It contains the text hello world. I can create a new hard link to that file through this other file. Okay. Now, if I were to cat new file.txt, it would show me hello world. If I were to cat temp new file hlink2.txt, it would show me hello world, because they both point to the same file. We haven't copied the file. Okay, this is different from copying. We could have copied new file into this other file, and it would have created a copy of this and made it into a new text document. But we didn't do that. What we did was we created two links to the same file. Okay. So now when we do the ls-l on these two files, notice now instead of one here, it says two. And the reason why is because this system knows there are two ways to get to this file. There are two hard links to this file. Okay. Notice they have the same permissions. They have all the same metadata, same owner, same group owner, same date of creation. Right? Nothing changed about the file itself. It's just a different path to the same file. So what happens if we delete the original file? It still exists. We can still get there because we still have a hard link that points to that file. And notice here, we cat this file and we get hello world. Notice that when we remove this file, what we removed was we removed a hard link to that file. So now we're back to only having one hard link to that file. Okay. All right. I'm going to show this, like I said, visually using the whiteboard in just a moment, but first I want to cover soft links. Okay, because soft links are different. Okay, for one thing, hard links can only point to the same files that are on the same same file system. Okay, I can only point to the files that are on the same file system. Okay. Soft links can point to files that are on a different file system. And we'll see we'll see something about that in just a moment. If we use the -s command line argument, then we're saying create a soft link. Now what we do is we're saying create a link of type soft. I want to create it to this file, and I want to call it this. Okay. So now when I do the -l on both of these, notice something different. There's still only one. The value is still only one here. And the reason why is because there's still only one hard link to the file. But notice this soft link that we created. Look at some interesting information here I want to point out. One, notice these permissions. These permissions are very different from what the base permissions are, right? The hard link file, these permissions are super different, aren't they? That's because the permissions are controlled by the file itself, by the hard link of the file itself. Okay. Anyone can view the soft link file at this point. Anybody. Because we can see what it points to, but in order to open that file, in order to read it, I have to be in one of these, right? In order to write to it, I have to be either owner or group. So permissions are different. Okay. This does not mean that someone can come in and write to this file through this soft link. They can find out information about this soft link to see what it points to, but they cannot get to this file unless they have permission to do so on the file itself. Okay. Notice also here, it's not just this temp new file symlink. It's saying that's the name of my file and I point to this other file. So notice a soft link doesn't change the number of hard links to the file itself. It also gives us the added information of this is a soft link that points to this other file here. Okay. Now, when the original file gets deleted, this is where we get some interesting stuff happening. The target's gone. The file is gone. There's no hard links that point to that file anymore. All right. But now, when we go to look at this, it's still saying, look, it's still saying, I point to this other file over here. Except the problem is, wait a second, this file doesn't exist anymore. Notice that this lost it here, right? And the reason why is because it's saying I'm pointing to this file. This is what I say I'm supposed to point to, but our system can't find that file, so we don't know where it is. We don't know what's going on with it. Okay, so when we try to open this soft link file, it says no such file or directory. So even though this file, we can see information about this soft link, we actually can't get to the target file because it doesn't exist anymore. So some ways that we can create those soft links. Again, the ln command creates a link. The -s option makes it a soft link. Okay. Also, another thing that this points out, hard links can only point to files. We can create a soft link to a directory. So here we're saying I want to create a soft link to the Etsy directory, and I want to call it this. So now when I cd into that, right, I go into the Etsy directory, but it's called something else. Again, this is not creating a copy of that folder. It's just creating a different path to get there. Okay. So let me go ahead and pull up the whiteboard if I can, if it allows me to, because I want you guys to see this visually. Again, some of you guys have heard me say this plenty of times before. I think visually much better than text. All right. So let's do this. So let's say that we have this file. Okay, we have this file out here on our system. Okay, text file, some type of thing. Okay, now we could have, let's call it link 1. Okay, and what happens is when we access link 1, it's kind of like it's a little memory that points to that file in memory. In a way, it's kind of like a variable. So I draw something like this is similar to a variable or a or an object in memory or something like that. Right. So when we use that ln command with no option, not the -s option, what happens is we create another way. We'll call it link 2. And we say, okay, I want to create link 2. Let's see. Try to get the order right. Sometimes I get messed up in the order. Right. So I want to create a hard link to the file that link 1 points to. And I want to call it link 2. And what happens is this just points to that as well. Now, when I remove, if I were to remove link 1, actually, let's do one more thing. Let's do ln link 2, link 3. We create this other thing over here called link 3. Okay, and it'll also point to that same file. Okay. Now, if we were to remove link 1, all right, this goes away, right? We get rid of this. But no, the file's still here. The file's still here. We can still get to it through these paths. Okay. But what about these soft links? Let me change to green for the soft link. ln-s, and we'll call it s-link. So, right, we got to create it to link 2. Right, link 2, because link 1 doesn't exist anymore, and we'll call it s-link. Okay, now we create this little pointer, we'll call it s-link, but we don't point it to here. No, that's not right. Okay, that does not happen. Okay, what it points to is it points to, oh, let me change back to green, is it points to here. Okay, so it's saying point to this that points to this. Okay, so it's a small little file that points to this thing over here. So now what happens if we remove link 2? This goes away. File's still there. But now what does this point to? This points to nothingness. There's nothing there anymore. Okay, so this is what's called that dangling soft link. And just like we've talked about in Java programming in your 101, 102 classes, is if we remove, and I won't change colors because we're almost done with this discussion, link 3, okay, so this goes away. This is now a file that existed in memory, but nothing points to it. Nothing gets there. So therefore, this file for is now really gone. We can't get there anymore. Okay, and just like what Java would do with garbage collection, it just goes away. Okay, so the hard link creates pointers actually to the file themselves. So it must exist on the same file system. A soft link creates a pointer to the hard link. So it doesn't have to exist on the same file system. I can point across to another file system to a different thing, but if I unmount that file system, if it disconnects, it becomes a dangling soft link in that way. And the reason why this is important, one of the reasons this is important, is if you've ever dealt with shortcuts. So like on a Windows operating system, we can create shortcuts, desktop shortcuts. You can put a shortcut inside of a folder to a file inside of somewhere else, right? That's the same thing. Basically, a soft link is like a shortcut on a Windows operating system. Okay. All right. Let's go back and finish up our discussion on here. And again, we'll look at some examples during the first few minutes of the next hour. Oh wait, searching. Sorry, skipped over the search. Okay, there's two commands that we can use to search for files. Okay, find and locate. So locate will look for files based on the file name or the path. Okay, so the database stores the file and name and path, and it'll just say, okay, I want to locate anything that has PASSWD in it, and it'll find all these different folders and files that exist on the system with that string somewhere in it. Okay, so notice it could be the end of it, it could have been the beginning, it could also be inside of it. Notice it's here. Okay, so it'll just basically, it's kind of like a wildcard on each side. It just looks for those files and folders with that word in it. Okay, so even if it's only partially the match, right? So password looks here, image, oh, it's a .image file, oh, it's an image as part of the name, all of it. Okay, now this is case sensitive, so it's only going to find file names and paths that have it as lowercase I, lowercase m, and so forth. But if I did the -I option, I'm saying, okay, I want case insensitive. I want to be able to find messages. I also want to be able to find messages with all capital letters. Okay, so this can be more useful, you know, but obviously it does require more on the computer to find it. Okay, so notice again, all caps, all lowercase, both. Okay, the -n option will say only give me so many options, only give me so many results. So if I'm looking for snow.png, but I only want the 5 results. I only want the specifically 5 results to show up. Okay, because I know it's going to be one of these top 5. That could be a reason you might use that kind of thing, especially for anything that might be where there might be a lot of results that would take a lot of time. Okay, now this does not actually search the file systems themselves. It's not like in where you're waiting for it to, like, this searches the database that has all of the that has the last captured file system structure to it. So if we update database, then it'll be with what is current. So let's say that 3 minutes ago, 4 minutes ago, we created a new file, and we want to, and we navigated away, we did some other stuff, and we want to find that file again. Well, if we do the locate command, it won't find that file because it's not in the database yet. So we can update the database to say, okay, I want you to have most recent information now. Okay. Okay, so it's a fast search because it uses the database rather than actually searching the file system itself. The find command, however, actually searches the file system. So it'll actually go through real time and find files that match certain criteria. And it's more powerful because we don't have to just do name-based searches. Okay. We can do name, Like if we use the dash name option, we're saying I want to find files that have I want to find. Oh, what just happened? Come on, highlight that.
SSHD_config.
Sorry, I don't know. It's like reading it to me. Okay. So we're saying I want to find files named SSH config. This is not a wildcard, by the way. It's not going to look for star SSH config star. Like it's not going to search for stuff that has that in it. It's going to search for files that are actually named this file. Okay. That doesn't mean that we can't use wildcards. We can force it to say I want to find all I want to find all files that end in txt by using a wildcard inside of quotes like this. Okay, so I want to find stuff named something.txt. I want to find stuff that in their name has the word pass in it. Okay, so then we get password, overpass, passenger, lots of different pass things. Okay, all right, so those are the name ones. Oh, and the case insensitive name. We can do that as well. All right, so that's where find is similar to locate, but now there's some cool stuff that we can do with find too. What if we don't necessarily want to find files with a certain name, but we want to find files that are owned by a certain user? We can do that. We can use the -user option to find out what files are either owned by the user student or by the group student. Okay, so we can find out files based on that information. All right. Or owned by a certain user or group ID. Okay. We can find files that are owned by a certain user and owned by a specific group at the same time. So we want to find not files that are owned by either user root or group mail, but specifically are owned by the user owner is group. The user owner is root and the group owner is mail. Okay. So a specific combination that we're looking for. Okay. We can also look for files that have certain types of permissions. Okay. We want to find files that where the owner has all permissions, the group has read and write permissions, and the anybody else has only write permission. Okay, we can do it this way. Okay, another example here. So this is based on the permissions of the file. So this is all files that have a specific permission setup. All right. Okay, we can match files in which certain at least factors are put in, right? So the user has read permissions, or the group has at least read permissions, or others have at least write access. This doesn't mean that it's going to match specifically 442. It's going to match where at least these things are true. Okay. Or the dash option, right? Where any file where the others have at least read access. So it doesn't matter about user and owner. We just care that the others have at least read access. Right. Or the permission here where the other has write permissions on that file. You can also use find to look up files of a certain size. File size can be exact, but that'll be difficult, right? This will find files with a specific size at least, or list all files that are less than a certain size. Okay. We can also search using find for date modified. Right, content was changed within a certain amount of time, right? File was changed to 120 minutes ago. File that was changed that's been changed more than 200 minutes ago. File that was changed less than 150 minutes ago. Okay. We can find files that are based on type. We want to find only the directories. Use the type option for that. And we can find the links. We talked about soft links and hard links. We can look at files that have more than one hard link. Okay, so we want files that have multiple paths to get to them. Right. So lots of ways that we can use find, and I went over a little bit for this first one. So what we'll do is we'll start at 11:02 for our second hour, and yeah, so we'll start at 11:02 for our second hour, and like I said, we'll do some examples very quickly, and then at 11:20 or so, 11:20 or so, we will go ahead and have our presentation. Okay.